Hi, I'm doing the final exam review today, and I'm going to do chapter 5 right now, which is working with polynomials. And some of this should be a nice review. Factoring might be something that is new to you, I don't know. But first things, just asking you to multiply. If you're multiplying something like this, you're just distributing. This is a distributing problem. Negative 8 times positive 4 is negative 32. We have the same base, and we're going to add the powers. N plus 2n is 3n. And the second one, negative 8 times negative 5 is positive 40. We're going to add n plus n and get 2n for our power. And then negative 8 times 1/2 is negative 4, and I have x to the n, and this is x to the 1, and those are not like terms, so all I can do is write that as x to the n plus 1. That's as far as I can go. That's all we want you to do there. Just remember here, when you're doing something to the second power, that's actually a FOIL problem. There is a shortcut, but I'm just going to do it out the long way. We have f, which is 3x times 3x, or 9x squared. We have o, which are the outside terms, 3x times negative 4y, negative 12y. We have I, negative 4y times 3x is negative 12y. And then we have L, which is negative 4y times negative 4y, or positive 16y squared. I missed something there, right? This is 3 times 4. This is xy, and this is xy. But it doesn't really matter. I mean, it does matter to us, and we want to make sure we have that in there. So we have 9x squared minus 12, and minus 12 is minus 24xy, and then plus 16y squared. So there are the terms that you have for your final answer. And just FOIL that. Make sure you're being careful with your signs and careful with your x's and y's, like I just almost made that mistake. Okay, the next thing you're going to be asked to do is factor. I've got 5 different problems to factor. Each one has a little twist to it. So I want to start off by talking about just take out a common factor. But notice, if you have something that's negative as your lead term, you want to take that negative out. And then the common factor here is 3, so I'm going to take out negative 3. And then for my powers of x, the smallest one I have is 2, so I'm going to take out x squared. When I say take that out, I really mean divide by that. And that gives me positive 2x squared. And that gives me negative 1x. And that gives me positive 6. And the x squareds are gone. So that's it. And then that can't be factored. At least I didn't intend for it to be factored. I just wanted to show you taking out a common term. The second one is factor by grouping. So what you do is you regroup your terms. Remember that every time you do this, your in-between sign should be an addition. So make sure you include that negative as part of the term. It goes to negative 15, not to the whole thing there. And now take out the common factor of x squared. And that gives you 5x minus 1. And take out the common factor of negative 3, and that gives you 5x minus 1. Notice when you divide by negative 3, it makes that second term a negative and the first one a positive. And now, if you've done this correctly, these two things should match, and they do. We can take out the 5x minus 1, and that leaves x squared minus 3. It doesn't matter which one of these you write first, but you don't write the 5x twice. The 5x minus 1, I mean, is what they have in common. So you write that one time out front, and then you write what they had that was different in the second set of parentheses. That's factor by grouping. The next two are factor trinomials, or all 3 of these are factoring trinomials. But again, I don't know what method you learned to do this. In these with the coefficient of 1 are very easy, because you're looking for 2 numbers that multiply to 21 but add up to negative 10. And so if you can do that on your own, fast forward for a second. You know, I always teach it using the box method. I don't think that Andrea teaches it that way. The bottom is negative 10x. The first term is x squared, and the last term is positive 21. So if I think of two things that multiply to be x squared, that would be x and x. And if I think about two things that multiply to be 21, I could use 1 and 21, but since I'm headed towards 10, I'm going to use 3 and 7. But notice if I multiply across, I would get 3x and 7x. That would be positive 10x, but I need that to be a negative 10. Well, that means that both of these need to be negative, which both of these need to be negative. You never put a negative in that first column. Negative 3 times negative 7 is also positive 21. And negative 3x and negative 7x add up to negative 10x. And then you take your answer off the diagonal. So I have x minus 3 and x minus 7. That would be how that would factor. Okay. In this one, before I can use the box, I need to take out the common factor. The common factor here is 3. That would leave 4w squared plus 6w plus 5. Right? It looks like it. And so now I want to try to box that thing. This is when these kind of problems that are harder than that last one are nice to have a method where it can kind of help you, guide you. The 3 is part of my answer, so I don't want to forget that. I'm going to write this over here. And I know I'm going to have to fill that other part in, but the 3 is part of it. So I have 4w squared, and I have positive 5, and I have positive 6w. I'm just thinking that I copied this down wrong, but hang on. If it can't be factored, I can't go on, right? But I'm going to give it a whirl here. But I don't want to waste a ton of your time, so I'm going to try, I'm using my calculator to see if it's factorable, which I'm not going to show you how to do that, but you could Google that if you wanted. Yeah, so I did not, this is not factorable. Well, how would I know? Because if I tried it, nothing's going to work out. I don't know what I wrote down there, but if I tried it, let's say I tried 2w and 2w and 5 and 1. That would give me 10w and 2w, never going to get me to 6. What if I tried 4 and 1? Well, that would be 20 and 1. That would not be 6. So no matter what I tried, nothing would work. So this is it. That's as far as I can go. I believe the one on your final, you can go further on that one, so beware. Okay, what about number 7? Number 7 has a common factor of 3 again. It also has a common factor of x. If I take out the 3x, I'm left with x squared plus 6x plus 9. And this thing I can factor. I can do that with the box or not. I have x squared and 9 and 6. This is going to be x and x. This is going to be 3 and 3. And 3x and 3x add up to 6. These are all positive, so that's nice. So that's going to be x plus 3, x plus 3, and that could be written as x plus 3 squared. Either one of those is okay. Okay, so I'm trying to look at the number that I had, trying to find where I had written down that example that I messed up. I'm not going to go back to it. So let's say I had this problem, 4x squared plus x plus 5, and I wanted to factor that. Let's say minus 5. So I have 4x squared here, and I have positive x down here, and I have negative 5 up here. Well, negative 5, the only thing I could do is 1 and 5. One of those has to be negative, but I don't know which one yet, so I'm going to hold off on that. So if I was to try 2x and 2x here, I'd get 10 and 2. That wouldn't work out. But if I did 4x and 1x here, and I multiplied across, I'd get 4x and 5x, and that could get me to positive 1 as long as something in there was negative. Which one should be negative? The 4 should be negative, and we never put a negative in the first column, so it would be negative 1. Negative 4x and positive 5x add up to x. That's true. And negative 1 times 5 is negative 5, so that's true. And 4x times x is 4x squared. So my answer would be on the diagonal, x minus 1 and 4x plus 5. So you can use the box to factor any trinomial that's actually factorable. This one was not, so there's no point in trying it, but you can try it, but there's no way to do it. You can't force the box to give you an answer if there's no answer to be had. Okay, for chapter 5, the next problem is this thing about Pythagorean Theorem. So Pythagorean Theorem says that, oh, you can't see it, that a squared plus b squared equals c squared. Remember, that is if we have a right triangle and a and b are our legs and c, then a squared plus b squared equals c squared. And this one says a wire supports a tree, so bum, 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 here's our tree. Well, that was really beautifully done. There's our tree, and one end is 14 feet from the tree. This is 14. There's one end of our wire. And the other is on the tree at a height, so it's on the tree somewhere. Bum. This is our wire supporting the tree. That gives us our right triangle. We know 14 for this side. And the wire is on the tree so that it's 2 feet less than the length of the wire. So let's say the wire is C. Then this is 2 feet less than that, or C minus 2. So everybody understand that? And so our a squared is actually C minus 2 squared. Our b squared is 14 squared, and our c squared is c squared. So that's that, and then I'm going to FOIL this, and whatever, what is that, 168? I'm always a little hesitant to remember without looking at it. 196, yeah, good for me. Glad I didn't just guess. All right, so if I FOIL out the left side, I get c squared minus 4c plus 4 plus 196 is c squared. Notice that the c squareds are going to go away here, because if I subtract c squared from both sides, that's gone. And I've got negative 4c plus 200. 4 plus 196 is 0, and I'm going to subtract 200 from both sides. Negative 4c is negative 200, and divide by negative 4, and I get c equals 50. Is that what they were asking? Well, they asked how high is it on the tree, and they also wanted to know the length of the wire. So the length of the wire is 50, and the height on the tree is 48 feet. All right, so make sure and read the question on the final. Which one of these are they asking for? They don't ask for both. Usually they ask for one or the other, so just be careful about that. Okay, and the last one, number 9, is solve an equation. That's a quadratic equation. It should have 2 solutions, but in order to solve it, I need to set it equal to 0. So first I need to FOIL this. X times x is x squared. Minus 6x and plus 1x is minus 5x. Negative 6 times 1 is negative 6. And then I'm going to subtract 8 from both sides. And then I'm going to factor this. Well, you could certainly use your table to factor this, your chart. Box, negative 5x at the bottom, x squared here, negative 14 here. X has to be x times x. What about 14? That's going to be 2 and 7. If I multiply across, I get 2x and 7x. Which one of those needs to be negative so that I get negative 5x? This one, and that means that. We never put a negative in the first column. So that means I get x plus 2 and x minus 7. X plus 2 is 0, or x minus 7 is 0. Negative 2 or positive 7. So that is your solution to that one. And that is what you've got going on for chapter 5. Have a great day.